Hello, ROS developers! Having problems creating Python 3 programs for ROS robots? Yes, I know, I had these problems too until I figured out how to manage Python virtual environments. Want to know the solution? Yeah, then you are at the correct place. This is the ROS Developers Live class, and we are going to start pushing our ROS learning. Hello everyone, how are you doing? I'm excited to do this live class because this is actually one of the live classes that some people from you of the audience have suggested to have. So we listen to you and then here it is. So we have prepared this and then I hope that you are going to learn a lot about this and it's going to be very useful for you. So the thing is that I'm going to start by explaining how this live class works so you can understand what you have to do in order to learn to take the maximum knowledge from this class, okay? It's just for the newcomers. So let me share with you this. So what we are going to do is to use what I call a ROS project. That is a ROS project that we have prepared with the content of this class. It contains simulation, ROS code, and notes for the class. So you are going to have this in a minute. And for that, how do we create those ROS projects? By using the ROS Development Studio, which is a tool that you are going to use. Okay, so you are going to use this tool that is online and is free. So on the ROS Development Studio, you create ROS jets like the ones that I have here, so different ones, and then those are ROS projects that anybody can execute in his computer, his or her computer. And it doesn't matter which kind of computer you have. You can use a Mac, a Linux, a Windows, and you don't have to install anything. So that's cool for the live class. So you can start practicing with me here and without having to prepare anything. We have prepared already everything for you. So stay here in a second and you are going to know how to. So what I'm going to do is for this live class that I have here, I'm going to share this ROS with all of you. How do I share? By clicking here and then copying this link to the chat. So we are going to do that in a minute. Okay, and then you are going to click on that link and then you are going to get the copy of this ROS that is the one that contains all the material that we are going to cover along today. That is the one that I am showing you here, okay, for this live class. So that is basically how it works. And then before we go to that, I would like to say hello to the people on the chat that I can see here many people. So I was chatting with Sebastian Castro, who is a guy, he's a very talented guy from MATLAB. So he knows a lot about how to connect ROS with MATLAB. You can ask him questions about that subject. Then we have Froggen Fury that she was telling me that she has some problems while doing Python 3 with ROS and never achieve it, and she doesn't believe that this is possible. We are going to demonstrate here that it is. And then we have also their Compute, of course, and Lucas also is here. And many Lies Wheels also we have here on the chat. Hello, and I can see many other people there. So welcome, all of you are welcome to this live class. You don't have to say anything on the chat, but in case that you have any doubt along this class, post it there on the chat on the side of this video, and then somebody will answer your question. I will try to be me, but there is also some people of my team, like it is, for example, Christian, who is an intern from the construct that he's one of the main creators of the code that we are going to do today, and also Ruben, who is there answering your questions. So between all three of us, we are going to answer your questions and see if you can move forward and don't get stuck. Okay, don't hesitate to put your questions there. I am very, very interested is that you learn a lot and you get a lot from this live class. Okay, so don't be shy, don't stay behind your computer, ask your questions and try to follow the steps. Okay, I'm going to go step by step. You have to do with me the same steps. Okay, so let's start. If there are no questions there, then let's start by sharing the ROS with you. So for that, I'm going to come here to my screen, and as I mentioned to you, so I have here the ROS that I have prepared for today, and then here it is a share button that if I click here, then I get a link, and then I can copy this link and go to the chat. I'm going to the chat right now, and then here is the ROS. Here is the ROS for today, and there it comes, the link. So there it goes. Then what do you have to do? You have to click on that link, and then by clicking there, it's going to automatically send you to the ROS Development Studio. And then you need to have a free account on that studio in order to activate this ROS, to open this ROS. So create a free one that's free, and then you can get into the ROS, and then you follow my instructions, okay, here on my screen. So I will wait for you to stay here on the screen. Let me wait for you here. So I'm here. Once you get the copy of that ROS, you should have a screen like this one that I have here, more or less similar, okay? So it depends on the ROS that you will have there. If it is your first time, you will only have one ROS, and mine, the one that I have just shared with you, and in case that you have other ROS, they will be around, okay? The one that we are going to work is this one, live class with one S. Very good, my mistake. I put one S. Number 81, how to use Python 3 with ROS. Okay, so once you have that, then press open on the ROS. You press open, and then some screen like this will appear. Then you leave the selected hardware as the basic one. Probably it depends on the amount of money that you have spent in the ROS Development Studio. So if you have spent 0, then you only can use basic, unless you buy something else, some extra GPUs or something, or extra CPUs, then you can select some of them to launch this ROS. This is the machine that is going to run the ROS code that we are going to use today. And this is a way that we make some money. So if you want to support us, then that would be great that you use one of our GPU or more CPU machines. Not necessary for this live class, okay? So let's go, then press open ROS. And by doing this, so you are going to get this screen that will open the ROS. And I already have opened here in the other tab, but I'm going to close it because it's opening again. So what else? So I'm going to wait here until it opens. Then it takes kind of a minute to open. In my case, maybe it's going to be a little bit faster because I already opened it. And in the meantime, I can check on the chat and have some coffee. Yes. So, I can see here that Marcus Vinicius has arrived, and Marcus is one of the clients of our academy. We have an online academy, it's called the Robot Ignite Academy, and there we teach ROS a lot. And Marcus is one of the guys who is making the most questions and finding all the bugs that we have in our system and asking a lot of questions. I think that he's learning a lot. And I can see, that then it's Pradeep Bena who has arrived, and also RZ. And also Marcus is indicating that he disturbs us a lot. Yes, but we are very happy to have you there, and we are there for you to answer your questions. So don't hesitate to ask us questions, Marcus. We are happy to have you, and also a person that is so interested for learning. So we very, very happy. Also, I can see that Matthew Hinton is there. Matthew, hello, how you doing? So a long time since the last time that we met here at the live class. So very happy to have you. Okay, my project has opened, and then I presume that all of you should have opened the same thing, the same way. So you should have opened and get this screen here. Then the first thing that you can see is this notebook that appears by default, open. And this is the one that contains the documentation with all the steps that we are going to follow along today. Okay, so this is your documentation. This is forever for you. You got this. You don't have to pay anything. It's for you. And so this is your reference when you want to try this. Then you want to use with other examples than the one that we are going to do here today. You can use this for reference forever. In case that you close this one, then this is called the Jupyter Notebook. You can only go to Tools here on the top of the menu and select Jupyter Notebook, and you are going to get the files of the notebook. Then I see here that Froggen Fury says checking remote machine address. Yeah, don't worry. So it takes some time, and then we have a few people, like about 60 people here opening at the same time, and then so that takes a while, but don't worry, it's going to open. Froggen Fury, let me know if it doesn't open for you, okay? That would be very strange, but it could happen, an error. Then my team is going to help you on the chat and solve the problem. So then, so what do we have here? Let's go, let's start. So if you get this page, I hope that you are getting this page. So what is this about? So it's going to tell you this. Let me remove this a little bit. So make it larger so we can see more stuff. And in the meantime that all of you that are opening, then let me explain you a little bit what we are going to talk about today. I can see that Froggen Fury has confirmed that her project has opened. Matthew is there. Hey buddy, yes, hey buddy, here, let's go. And then what else? Then we have here. Yusuf Imam says, this is my first class and I joined just now. Okay, so Christian is going to help you to introduce. Please, Christian, help Yusuf to get up to speed, okay, while I'm moving forward for the rest of the class. So this is called teamwork. So what is this ROS with Python 3? So the important thing, the problem that we try to solve is that you have some libraries that are written in Python 3 and you want to use them in ROS programs. But ROS Classic, let's say ROS Classic, ROS Kinetic, ROS Indigo, ROS Melodic, it works only on Python 2.7. Then what can we do? So this is the procedure that we are going to teach you along here. And we have created this project that contains code, simulation, and documentation between Christian Chavez, who is on the chat, and myself. And this is for you, so you can use it. So for the class of today, you should have some requirements. So you should understand the basics of Linux, because we are going to do some commands. I mean, not a lot, but we are going to do it. So if you want to understand, you need that. If you don't know about basics of Linux, I highly recommend you this free course online that we have created, which is called about Linux for robotics. So we have distilled the knowledge of Linux into what it is actually required for robots. And it's a free course. So you have the link there, you can test later. Then also we have the ROS basics. You have to understand what is a topic, what is a package, and so on, if you want to understand here. If you don't, check this online course where we teach how to do all those things for ROS basics. And finally, you need to know about Python 3 for robotics. If you don't know about Python 3, then you can learn. Also, we created another free online course here that is specifically targeting people that want to use Python for robotics. Check it out in case that is so if you don't know very much. So in this case, what I mentioned is the problem that we try to mention. So what we are going to do here is to follow one concrete example, but you're going to see the steps are the same. So I'm going to abstract the steps for any other case. So for example, Sebastian on the chat was saying, I want to use it for compiling OpenCV, the CB bridge, specifically the CB bridge. Okay, so I haven't done for that specifically, I haven't used it, but we have done the same procedure for TensorFlow 2, for OpenAI baselines, the example that we are going to do here today, for PyTorch also. So you can apply to any of those that follow these structures. So let's see, let me explain the procedure, and then Sebastian, in case that you say, oh no, but this case OpenCV is different because blah, blah, just tell us, and then I will have a look after the class and check and figure out how to do it and then post it for the whole community, including you. Okay, so let's go. So the first step in order to make this work is to define the situation. So this is always the first step. You have to define what you want to achieve and what are the involved parts. So we want to use the Kubli robot. Okay, so we are going to make some code to command the Kubli robot that you can see here on this picture. That is a cube that contains some spins in the inside and makes it the spins, you can stop them and move fast and then make the robot move around by making a spin and then stopping. So you generate some inertia that is used by the robot to move forward or backwards or stay in a corner like in this picture. Then we want to make the robot learn to move forward by using a learning algorithm that is the OpenAI baseline DeepQ, which only works for Python 3. So those OpenAI baselines are state-of-the-art reinforcement learning algorithms that you can use for training your robots. But the problem is that they are created only in Python 3. So how do we do that? Okay, that's the definition of the situation, okay? Then in order to do that, also we'll need to use the OpenAI ROS package. It's a package that we have created and it's for the community that allows to interface OpenAI baselines with ROS, but still have the problem of Python 3, okay? So this is just for interfacing the API of OpenAI baselines. So still we need to do all the trick for making Python 3 work on ROS Classic. Okay, so that's a problem. We have to find that. Okay, so let me show you the code that we have created, and it's included into this ROS yet, so you can check it later. This is the code that we have created to train this robot. So in order to see the code, go to Tools here and select IDE. Then a new window should open, and then here there are several workspaces. There is one workspace here that is called Catkin workspace. So if you go inside and then go to source, then you can see here the code. This is the code required to training the robot, and it works with Python 3. Okay, so this is already provided by us for you, so we are not going to create that code here because that's not the issue in this live class. Okay, so I assuming that you have some code in Python 3 that should interface with ROS robot. So this code here is the one that is connecting to ROS to the ROS robot, to the ROS robot, actually, to the ROS topics, ROS services, and so on. But they need to interface also with the baselines of OpenAI, and those are the ones that are written in Python 3. Okay, so those are the ones in Python 3. So how do we interface all that? That's the point that we are going to see. Then for that, what we are going to do is to create a Python 3 virtual environment inside our Python 2 environment. Okay, so I mean, this ROS computer that you are seeing here is it's a ROS computer with Ubuntu 16, ROS Kinetic, and Gazebo 7, and this system is based on Python 2. So let's create a Python 3 virtual environment inside there. So how do we do it? We need to have a terminal. So let's go to Tools and then select Shell, a terminal. And I'm going to put it here, for example. Then let me see, it's taking some time to connect. That's a good moment to take some coffee. Let me drink it. Then I see that there is a guy there that is called Anton Matosov that says, my IDE window is blank. And try to use another browser. So this is Firefox. This works with Firefox and also with Chrome. So try any of those. Okay, so here it is, the terminal, and I can do an ls here, and I can see all the workspaces that are shown here in the IDE. Okay, so you can see the same structure. So okay, so we are set up. Then I have a problem here with the connection. Okay, so solve it. Yeah, but okay, I don't know what could be that. I don't know. Anyway, let's continue. So the first thing is that you have to install the basic Python 3 packages in your system. So in that case, we don't need to install here because they are already installed. But in case that you would like to use this in your own machine for your own situation, just make sure that you have installed your Linux system with those packages that you have here. So as you can see here, I mentioned at the beginning, we are doing a specific situation for this computer, for this example, but we are providing also the tools for your general situation in case that you don't have those installed. Great. Second thing, we need to install Python virtual environment in your computer. So that's the sentence to do it. We are not going to do it here neither because we already have installed it for you. So that's one of the advantages of working in the ROS Development Studio. We are so pretty. Yeah. Okay, then we have step number 3. Here we have a question from Sai Charan that says, hello sir, can I follow now? And yeah, of course you can follow, but you will need to go a little bit fast. So you have to go you have to go up in the chat and look for the link that I have shared. Click on that link and then it will follow more or less automatically up to this point, more or less. So try that, Sai. Okay, then step number 3. So we are going to create and activate the virtual environment of Python 3. So how do we do? First, we create a directory that we are going to call our Python 3 workspace. Okay, so that's the name that we are going to do it. You can provide any name here. I recommend you that here for today, just respect the same names that we have, so you can you can follow easier. Then afterwards at home you can do whatever you want. Then let's create a directory mk. You have the command there, but it's a very simple command for Linux. So then what this is creating is a Python 3 that we call workspace and the source directory inside. So now you can see here on the IDE that it has appeared the Python 3 workspace, and then we have a source, everything empty. Okay, so let's go and let's start populating all that. So the first thing that we need to go is to go inside that directory, go inside, and then we are going to define this directory as a virtual environment. The one that contains the virtual environment. So for that, you have to type this command that is virtual environment, and then you provide a label for that virtual environment. So one thing is the directory name, and another thing is the label that we are going to provide to the virtual environment. So different things, and you're going to see why in a minute. And then you specify which type of Python you want to use in this virtual environment. Okay, so very easy. Whoops, I copied the wrong thing. So that's the ROS that I share with you, and I'm coming here. No, because take care that not to copy the $sign. The $sign is just this representing the prompt here, so don't copy that. Then yeah, so you are inside the Python virtual environment, the Python3 workspace, and then you issue this command to create the virtual environment. So now the system is going to create this, use this directory as a virtual environment for Python3. Okay, so we have everything set up, so you can do an ls and you will see that some extra things have been created. And now let's activate this. So in order to activate, you have to use this activate command that has been generated inside this other directory. So in order to not to miss anything, just copy this command that it is completely, so it contains everything that you need to activate the command. So basically it's a source from this activate file that has been auto-generated. Okay, so now you can see that the prompt has changed, and now it's showing us the label that I mentioned before. So that is why you need to provide a label. So you know that in any point in this terminal, you are in a Python3 virtual environment activated. So anything that you do here is going to be Python3 related. Okay, so far so good. Okay, so this is a step number, well, actually it's a step number 1, is to create and activate the virtual environment, the Python3 virtual environment. Okay, so we have that. Now we have to start using this to populate with all the required libraries and dependencies that we are going to use. So for our case, we wanted to use the baselines of OpenAI. Yeah. In other cases, you have been telling me on the chat that you needed something of OpenCV, sorry, OpenCV, and also some other people were saying about PyTorch, I think, or I don't remember. Well, the thing is that in that case, you have to go to your source directory and install there your libraries that you want to compile and that you want to use. So let's go to our source here. We can go to source directory directly by doing this command, or you can use the command that you have here, that is the save command with the whole path. And then I'm going to clone my libraries. In this case, that would be to install here, to clone your own libraries, the ones that you want to use. So I know that this get is for baselines, so I'm going to copy them here. So copy this command, git clone, and execute it. So it's going to download the libraries that I want to use, the baselines, remember. Okay, so now, those are Python3 libraries, and usually they have been downloaded, but now we need to install all its dependencies. So for that also, again, you have to look at your specific library requirements. In this case, I know that baselines require to install TensorFlow in this way, in this specific way. Why? Because baselines indicated like this, that they need to install like this one specific version of TensorFlow. So that's what we are going to do. In order to install this, so we need to issue this command, pip install, and then TensorFlow and the specific version that we want to. We are going to move inside the CD baselines for another reason that you're going to see in a minute. So let's go first inside the baselines. And once here, let's issue the pip install command. It's going to take a little bit. Okay, so this is one of the dependencies that my library that I want to use that requires. So I want to use, for example, let's say OpenCV. I want to use OpenCV 4. Okay, so then you download like this, git clone your OpenCV files. Then this OpenCV requires to install some dependencies also. Okay, then you are going to install here also the dependencies, all the dependencies. Then in this case, we install first dependency with pip install, and also here, after everything has been installed, we are going to install additional dependencies with this other command. This is very specific to baselines. Usually you only need to issue this command, but in this case, so for, I don't know, problems in the baselines, I don't know why. So it requires that we install TensorFlow in this way. So that was explained in the baselines documentation, okay? So it's not something that I have figured out or decided. It's not my case. So we have a question, very interesting question, that GUI Seidner, he's asking, says, why are we not issuing PIP3? And that's a very good question, GUI. So the reason why is because if you type pip in one terminal, then the pip version that is going to be executed is the one of the default Python that is activated. So remember that in this terminal, we have activated the Python3. That means that the pip command is going to activate actually pip3. So if we were in another terminal without Python3 activated, then issuing pip will be equivalent to pip2. Okay, so TensorFlow has been installed. Now let's add this second command. Remember that in order to issue this command, like this, pip install -e dot, you have to be inside the baselines directory, okay? Because it's the command that is going to install all additional dependencies of baselines apart from TensorFlow. Marcus is indicating that, let me see, Marcus Benithus, what is TensorFlow? TensorFlow are some libraries from Google for deep learning that baselines are using. Then we have another thing that Charan says, I think it is pip3 install. Okay, so pip3 install in this environment is the same exact as pip install without the 3. Because of what I mentioned, because Python3 is by default the system of this terminal now, so you don't have to. Okay. Then so I can see here also could not install packages due to an inventor error. So Frog and Fury has a problem there on the chat. Frog and Fury, are you executing this on the terminal? That doesn't make any sense. You are trying to install something in a Python 2.7 environment. So I think that you are doing something in your local computer. Could it be? Okay, so let's continue. This one has been installed. Then we have this error of Jim. Don't worry, it's not an error. We are going to correct this in a moment by installing this final install Jim. So this final command install pip Jim. Pip install Jim. Okay, and then this is correcting the error. Basically, it's because we have installed a Cloud Picker version that is higher than the one required by Jim. And then when we do this command, then Jim is resetting the Cloud Picker to the version that it requires. So everything is solved. That's not very important, not related to the problem of Python3 with ROS. This is just problems with installations of libraries that you have to solve your own. I mean, we cannot cover that. Okay. Then, yeah, so Anton says pip install -e dot for baseline install Jims as well as the rest of its dependencies. Yes, that's right, Anton. That is right, but for some reason in the final version of baselines, they are requiring this version, and it has changed the default version of Cloud Pickle to 3. So that is why it's making this error. So we decided to add this final command in order to correct that error. Okay, so that's the only reason. And then in general, you will be right. And then in general, you would not even need to do this TensorFlow. So yeah, so this is a thing for installing libraries and those things, and then you will have to figure out your case. Okay, so far so good? Great. So now, what do we have now? We have a Python 3 virtual environment created and activated. So we have that here. Okay, that's very important. And then we also have all the Python 3 libraries installed along with its dependencies. So far so good. We haven't done anything about ROS yet. Okay, so still our code here for training the robot can. Okay, so there was a kind of a problem in the transmission, but I think that we recovered. So what I was saying now is that so far so good. So we have not installed anything related to ROS, and now is where it comes. Then some people say, can you move the shell a little bit above? So you should be seeing, let me see. You should be seeing the whole shell. Okay, so let me do one trick in real time. I don't know how it's going to appear. So let me do this. And let me see if we can see here. Okay, so let me show you here. Yeah. Okay, so far, and then let me do like this. Yeah. Okay, now you should be able to see everything. Okay, so let's continue. The most important point is the installation of the ROS packages required by your ROS code. So that means that if your code, your ROS code here is going to need some ROS packages, then here is the bad news. Here is the bad news. You need to install the ROS packages that your code needs and recompile them in Python 3. So you need to install them in source and then recompile them. That is the trick. That is the part where it could happen that your code, actually the ROS packages will not work off the shelf recompiling. So you will not be able to recompile them for Python 3. It may happen. So then you will have to go to the code, to the source code, and correct the problems. For example, we have tried to use MoveIt for moving arms and recompile them with Python 3, and it didn't. So then you cannot use it. You cannot apply this trick. Then I will tell you by the end of the class another trick is the final trick, okay, for that is in order to make it work. But it's a kind of it's a dirty thing, but we'll see in a minute. So what we need to do is to install the ROS packages required by our ROS code, by the training algorithm. So I have figured out in my case that I need to install the geometry and geometry 2 packages of ROS. So that's what I'm going to do. So inside the source directory, let me install all the packages of ROS. You see, I'm cloning them, the source code from ROS. So let's do that. We need to go one directory up here and then go to execute those git clone. So first, let's clone the geometry packages here. I'm cloning it. And then let's clone also the geometry 2 packages. Okay, so now we have the 2 ROS packages that I need to use in my ROS training code. But those ROS packages, in order to be compiled, they also need to have some Python dependencies. Then this is the point that we are going to do right now, is to install the dependencies of other Python packages for those ROS packages. Okay, so those, they require to install PyYam, ROS package, and mpy. Those ones, they need to be installed in Python 3 versions. Okay, so if you don't have those in Python 3 versions, then you will need to download the source, recompile, and do whatever it takes in order to install the dependencies of this also in Python 3. Fortunately, for our case, we already have that. So we can copy this pip install pym. So let's install the first dependency of ROS, of our ROS packages in Python 3. Also, let's install the other one, and also let's install the other one. Remember that everything that you are installing here is not being installed inside the system, the main Linux system of your computer. It is only installed inside this Python 3 virtual environment. So it's like you have created a sub-world of Python inside your main computer. And let me put it, maybe here you will see better also. Okay, so far so good. Then it's time that we compile our ROS packages that we have installed, the sources. Not yet our ROS code for training the robot. Okay, so it's not yet, just compiling the dependencies in ROS. So for that, we need to go one directory up, is on the Python workspace, and issue the typical command that you already know. It's catkin make. Okay, catkin make, but we have a specific flag to provide, is to indicate that it has to be compiled with the Python 3 binary that we have installed in this virtual environment. Okay, so you issue here the catkin make with this flag -d Python executable, and then they provide the file path up to the one that is inside our virtual environment. So here is the Python that needs to be used. And then let's compile. So this is going to take a little while. And in the meantime, I'm going to drink some coffee and also see if there are any questions or any doubts on the chat. If you are following, then Frogen Fury, you never told me if the problem of the permissions were solved already. So I would like to know about that. And also I would like to know if you are following, if you have any change, any not solved. Okay, so which command did you issue, Frogen Fury, in order to get that problem? Which one is the command? Copy paste here. Also, let me see, then the question of Sai about the shell is done. Also the Yusuke also asks the same thing. Sai Charan says Stack Overflow helps a lot. That's correct, yes. Then Jover Michael Castro Campos says, I got an error. It says CMake error. Could not find Python interpreter found in suitable version 1.4, but required at least 2. Yeah, I think that maybe you didn't copy. Jover, it looks like you didn't copy the proper path, the proper command. So check that this command it's longer than the shell, so you have to copy everything. Okay, so check this, Jover, and have a look. Then Marcus Vinicius says ROS is like a patient that needs transplantation of several organs from different people. The doctor is the ROS developer, not easy task. Yes, that's very fun. Yes, all us ROS developers, we are the doctors. Yes. Then Frogen Fury, pip install TensorFlow, blah blah blah, and then you got that. No, I don't believe you. So are you using this in our system or in your local computer? So what are you doing? That doesn't make any sense, because I mean this is the same environment for everyone. But you had to copy Oh, the command, like it is there. I mean, it's, you are using Chrome then. Pip install, then you got this error. Let me see. Let me see if I cannot check the error there. Pip install, it's correct. So it doesn't make any sense that you have this problem. Permission denied. You should not be. Do you have the Python 3 environment activated? So do you have this Python 3? Let me see. So you have this label here activated, Frog and Fury. And then it says having some red errors related to TensorFlow and 6 while installing ROS package and PyIM. Okay, let me see. Let me go up. Also, some other people are having some problems in there. Let me check. When we were installing the Python, no problem, not a problem. So you cannot have a problem basically because you are executing the same exact environment as I am. So Sebastian Castro says, I got that error if you install without activating the virtual environment. Yeah, so that's what I mean. I think that's your problem, but I cannot be sure because I cannot see the... So it looks like you are trying to get, because it doesn't make any sense that you are going to use locally Python 2.7. So, okay, thank you, Sebastian, for posting the command to activate. Yeah, thanks a lot, Sebastian, for your support there. Okay, let's continue. In my case, well, I don't know if we have to continue because it's important that you do that it works for you. So say Charan says pip install TensorFlow equals 111. Yeah, RC2. So are you copying the command from here? So you should copy from here. No more problems. So you copy and then it's going to work. I'm showing you here that it's working because I mean I have nothing special and different than you. It's exactly the same environment that you are executing as me. So it depends on the steps. Okay, so far, so what we have is completed the compilation of the ROS packages that we need in our training code for Python 3 along with its dependencies. So we have a complete set of ROS packages that work now in Python 3. Then in order to activate, to get those packages ready, we had to do a source, as you know, in ROS. So we had to source the Python 3 devel setup bash that has been created during compilation. So it looks like we are getting some problems in the connection and in the internet connection. I hope that it is recovered. So what I was saying is that now, yeah, you should get it. Then is that this Python 3 workspace is a directory that contains this virtual environment complete. And people say it's completely frozen. No, you should get it. Don't you get it? Yeah, I can see that my changes here. Yeah, okay. So, yeah, so this Python 3 workspace is the one that contains everything that we have installed. You can activate on any terminal that you want to use those configurations, those libraries. So that's another key point. So for example, so I'm going to compile those packages, but I'm going to open a new terminal, or this is a new day, so I close my computer and then I'm going to start. So I open a new terminal, and then bear in mind that this terminal has not activated the Python 3 environment because it's your default terminal. So the first thing that we need to do is to activate the Python3 environment that we have. So any other day that we come here and we want to compile new things using the Python3 for ROS, so we need to do and source and activate the Python3 environment on any terminal that you open, okay? So you need to see this label here. This is indicating, okay, now you are in a Python3 environment, in the one that you created. Also, we need to source the packages of ROS that we have created and compiled. So now I am sourcing my code of ROS with Python3. Okay, so now I can go to my Catkin workspace, where I have my own code, the code that I want to compile with Python3. So the first thing that I'm going to do in order to not to do some errors is to delete the build and devel, because it's very likely that it's mixed with Python 2, Python 3, whatever the mess that we have there. So in order to start clean, first thing, delete here your build and devel from your code. So you will know for sure that you are starting with a clean Python 3 environment. So let's do rm minus rf build and devel. Okay, so now we are going to compile. How do we compile? Using Catkin make. But let's specify again the command that indicates the specific Python binary that we are going to use. So this is the command. It's Catkin main minus d Python executable file path, and then the binary that we have installed in our Python 3 virtual environment. That's it. So now it's going to execute this and compile everything and so on. And then at the end, that's all. In our case, I know that it's going to compile everything and we are going to have no problems. And it's going to work. Yeah, done. Compile. Then Program Fury says, somehow the first virtual environment I created were bugged. Okay, so yeah, that's normal. Don't worry, Program Fury. It's the first time that you are doing this, so it's and you are trying to attend to the screen and try to do it. So I understand that this is a little bit complicated. So don't worry. We figure out and then you solve it. Then ROS Agriculture says, looks good now. I think it's for the screen. Great. Hello, Matt. How you doing? Always a pleasure to have you here. Always a pleasure. Okay, so we have everything compiled. Then it's time to launch and see if it works. Oh, okay, wait. But first, let's source the results. Okay, as always in ROS, you know that. So source, devel, setup of the Catkin workspace, and we have everything ready to launch it. So for this, we have prepared a simulation of this Kubli robot. So remember this Kubli robot? So we have created a simulation. It's not very pretty, it's not as pretty as this, but it has one spin motor inside. So it's working on the same way with one spin motor. So the simulation is here in the simulation workspace. You can have a look afterwards if you want. Here is a moving cube description. But now we are going just to launch it. And you can launch it through the terminal, but I'm going to do it by using the menu here. It is faster for now. So let's go to simulation, choose launch file, and then here in launch file, go to the drop down menu and select the main.launch file. Then press launch, and it's going to launch the simulation. We are going to have it in a minute. Then we have another question from Program Fury, and she is really a fury asking questions. So go ahead, let us know what is your error. Program Fury. GUI designer says, and pray. Yes, and pray. Let's pray that everything is working. But so far so good. Is launch and pray. Yeah, that's what we meant. Yeah. So we should get something like this simulation. It's loading here, and it's going to appear. And here we see a moving cube doesn't exist. Very good. And controller spawner is not working. Okay, so couldn't find the expected controller manager. No way, no way, it didn't appear here. For the final moment, the moment of truth. I cannot believe it. I cannot believe it. Okay, so the model should be here, so it should appear here. Let me see if I have deleted anything here. Moving cube. Let me retry. Okay, let me retry. Let's retry. I don't know why we retry. It's stupid, but okay. Yeah, it says moving cube doesn't exist. It makes no sense at all. Really, it makes no sense at all because this is completely tested already. No, yeah, it's get state model doesn't, moving cube doesn't exist. Okay, let me do one thing. Let's close the simulation. You can close here on the corner. Then let's do one thing. Let's launch it manually and let's see what is happening there manually. So it's in the simulations workspace. So I'm going to, well, actually is ROS launch moving cube description main.launch. Let's see what it says. I was trying to go faster, but it doesn't go faster. So the root link cube body has an issue specified. Okay, that's not an error, just a warning. Then process has died, then blah blah. And yeah, controller spawner. Yeah, because it has died, then it doesn't. That doesn't make sense. Dynamic module doesn't define init function. Okay, so import TF transformations. It's here the problem. Yeah. No, but that doesn't make any sense. A spawn model, so it's on the spawn model function. Okay, so that's not, makes no sense at all. So let me do one thing. Let me do one thing. So I'm going to close here and I'm going to go. Never do live classes, guys. This is the moral of the story. You prepare everything and then at the end you get this. So come on. Okay, so let me recompile the simulation. I don't know what is happening, so I cannot give you proper instructions because I don't know. I try to figure out what is happening. So let me make this. And let's compile a simulation, then source it, and then launch it and see if that works. And if it doesn't work, then I don't know what is happening. I don't understand anything. In the meantime, let me check this ROSDEP helps. No, not in this moment because it's already done. It's already, the dependencies have been already installed. So this is a simulation that we have created here. So everything moving cube created. Let me launch it again. So let's see if it goes. If it doesn't, then no. Okay, that means no. This looks like it's a problem in the main system. So it's because it's on the spawn model from Gazebo ROS package. So that's the problem. Let me check if another simulation like an empty wall with a robot. Let me put a simple robot, not very complex. I don't know, the simple robot. Yes, no, the Summit Excel. No, not Tiago. Summit Excel. That always works. So let me launch it and let me see. Then I think I fix it. Sebastian said in the moving cube URDF, add this inside the plugin tag. Then legacy mode and S2. Okay. So let me see. No, but it's okay. So it's a problem here also. It's so no. So Sebastian, you mean that you solved it? Let me put the turtle bot also. I don't know. That did not fix it. Yeah, just a different error. Yeah, yes, because it's true. So that's something in the system itself. This makes no sense at all. Makes no sense. Let me tell you, makes no sense. So we have been working with this until 5 minutes before. And yeah, so that's failing again, spawning, and so on. Okay. So what can we do? See, if we cannot test it in the simulation, so the only thing that we can continue is by launching the code. So I will have a look afterwards and see what's happening and see, yeah, so this, we can close everything. So don't worry about that because this is for the simulation, okay? So that was the grand finale. And we try to make it more spectacular because that means that everything is working. We can test it with this launch file. But the whole process that we have done is correct and you can apply to your own situation. So it's finally we have this application that is the one that we wanted to launch is by this final command is my moving cube package start training. So you can launch it, but the problem is going to start to complain that it cannot connect to the robot and so on. So remember to launch this command always in a virtual environment. So in the virtual environment, activate it and with all the packages that you need for ROS2 and libraries, source it. Yes, and then Sai says, it's fine, the part we wanted to cover is to use Python. Yeah, that's correct. Yeah, but I mean, we wanted to show, hey, that works, and then it's showing with a proper thing. Also, you got here the code of the simulation, the code of the training, you can reuse afterwards and so on. Well, so anyway, let's finish here. You got the whole thing. And then just remember, it's a very important thing to remember that in any terminal that you want to use this code, this Python3 environment, you need to activate it first, okay? Because otherwise you will be on your 2.7 environment and then it will make no sense. And that is all for today, guys. So if you liked this video, please support us. Support us. How can you do that? Well, you can support us in different ways. The easiest way, give us a like on the video if you like it on YouTube and subscribe to the channel, please subscribe. So you can do it very quickly from there, from where you are. Also, you can buy one of the ROS developers t-shirts like the one that I'm wearing here. You can see this one. I am a ROS developer. Are you? Then you can get one of those. And also you can subscribe to our online academy. That is the one wait, sorry, I pressed the wrong button. Sorry, I pressed the wrong button. Then, yeah, so you can subscribe to our academy where we teach many different things and subjects about ROS. And that's it. So I have some minutes for questions and answering for you guys. So I will be happy. And also I have another proposal for you. It's a surprise. I would like to know your opinion, okay? So let me see here on the chat, what do you say? So say Charan says, it's fine, sir. Very good. Say, thank you very much for your support. Then Ricardo, could you please, in the end, summarize the goal of this class? I am not very familiar with OpenAI yet. I just finished the basics module now. Okay, yeah, Marcus, the OpenAI here is just an example. It means I wanted to use the OpenAI libraries with a ROS robot. And the OpenAI libraries are written in Python3, but the ROS robot doesn't understand code in Python3. So I could not use the baseline to reinforcement learning train my robot with those libraries. And I want to use them because they are very good. They are created by super genius that are in OpenAI. Those guys are the best of the best. So I want to use their stuff. And then for that purpose, we need to create this Python environment where we are going to get inside there. We are going to install these ROS packages that I need, the dependencies of those ROS packages, and then compile everything. And then from that point, I'm going to recompile my code. And then my code will be able to execute Python 3 code of the baselines. It's like a bridge. Then let me see more questions here. Then last question, does this work with Anaconda too? It looks similar. So I don't know. Yeah, I presume if Anaconda is a library, so Anaconda is like a system with for installing packages and so on, isn't it? I haven't used very much. So I suppose yes. So I cannot give you more details about that. Guy, thank you, Guy. Thank you, Sai. Also, Rishab, thank you very much. What's the next session? I'm going to tell you about the next session. 1 minute. Sebastian Castro says he got it working. Great, Sebastian. Yes, I told you at the beginning of the class that Sebastian is a super master. I told you. So I don't know why he is in our class. Okay, so maybe we need to go to his class. Then, what's the dirty hack you mentioned earlier for packages that don't work? Okay, that's a very good question, Liz Wills. This question is, when you have a program that doesn't work with Python 3 and you cannot recompile it in Python 3 as we have done with other packages like geometry or geometry 2. So one example is MoveIt, for example. We tried to compile MoveIt for Python 3, but we couldn't. And I mean, you can dedicate a lot of work in order to make it compile, but we couldn't. I mean, we don't have the resources. So for that purpose, what we did was to do a bridge. And then in this bridge, we execute the code that only works on Python 2. We execute it in Python 2. But then we create a ROS node. This is a ROS node that can communicate through topics to this Python 2 code, through topics, communicates, and then it is compiled on Python 3 using the method that you have. So this, you have to create this bridge because it's specific for each application. So depending on which application you want to use that cannot be compiled in Python 3, then you launch it, then you decide which topics or services you want to connect, then you create this bridge that it is compiled inside Python 3. And then all the rest of your code, it is using Python 3. All the rest. And this bridge communicates from this from this side with Python 3 and then communicates with the other part on the other side with the Python 2.7 part. It's a little bit complicated here, and we have done this in order to implement the her algorithm for fetch using MoveIt. But it's a lot of, I mean, it's a little bit complicated, but I hope that you get the idea. Then we got here a message from, also from Rishab says, how can we use it practically? What do you mean practically? We are using this practically. So we are training our robots in the construct in my company. So we are training the robots using OpenAI baselines, and we do all the work by doing this. So that's practically. So in any other, for example, OpenCV is a case that some people were mentioning there. So you need that in order to process the images of your robot, then that's a practical case. So you can use this, is the right way of doing it. So Sebastian Castro says, I started a ROS core in a shell. Then I used the simulation to just run your start wall. Use the terminal to ROS launch, the moving launch, and then it worked. Okay, so it's like you're telling me is that you are not using the ROS core of Gazebo itself. For some reason, there is a problem there in the communication. And then you mentioned that, then I think that I know what could it be, because we have been playing with IPv6, and then this could be some problem of routing or something. Okay, I don't know. Thank you very much, Sebastian, for figuring out the solution. You can check on the chat. This is the solution for that case. Marcus says, thank you. So virtual environment is different from the root. Yes, that's right. Then, I don't know, just to check as well, instead of installing all of ROS, it's just done package by package. Yes, that is right, because you want to avoid to compile as much as possible. So you only want to compile the ROS packages that you need. Then, thank you, Heath Thank you very much. Then Marco says, hi Ricardo, did you ever use Intel Movidius? Okay, no, I'm sorry, Scafuro. I'm taking note here, Intel Movidius. Okay, so I'm going to write down something related to that and search for that. Okay, so Intel Movidius. Okay, no, sorry, Marco, cannot help you more. Then we have I came late, the Jupyter notebook is well written, I could follow you. Yeah, Fred, very good, very good, very good. Frog and Fury, thank you, sir. I will try on my own machine and see if it works. Yes, okay, I hope so. Then Marcus says, now everything more clear. Great. Thank you, Liz. Thanks for the reply, Rishab. Okay, my pleasure. Then want to tell you one thing. I have an idea about the future, kind of doing book club about robotics and artificial intelligence and how to apply all that. So the idea would be to decide a book for the month, and then all of us, we had to read that book, and then by the end of the month, then we can do a kind of a live class, an extra live class where we discuss together about this book, what are the main ideas. So here I brought 2 examples of books that we can read. For example, this one is one of the latest one about rebooting AI, and about building artificial intelligent machines. This one, it's becoming a classic, super intelligence. It's about machines becoming super intelligent, but there are many others, so we can decide. So let me know on the comments below of the video, what do you think about that? Would you be interested on that? I will be reading one of those books per month and then doing some summary or something that we can discuss together. So let me know what you think about that. And then finally, I would like to tell you about the next live class. So let me go here and change. Here, what we are going to talk on the next live class is how to create courses. So how can you create courses for our academy that we are going to buy from you? So we are going to explain how you can create your own course about the ROS subject or robotics subject using our environment. But using the environment is for free. So you can see here some of the steps that we are going to cover on the video that you see on the screen. So we are going to cover some of the steps about how to create the notebooks, how to create the code that you are going to provide to the students, the exercises, how you are going to test on the simulation itself, and so on. So that's the next live class, and then our purpose is to buy your courses because we are going to publish them into our academy. So you know that we have an academy, it's called the Robot Ignite Academy, and there we teach ROS and we create the courses, but we want to open our academy to third parties, so you can create courses that we can publish there and get paid for that. Okay, so this is going to be next live class. I'm going to show you all the things. It's a lot of fun to create the courses and get paid for creating ROS courses because you practice a lot. You get really into the deep of the subject because you have to explain to somebody and create the proper steps in order to understand, like in the live class that we have just prepared. So that's for the next live class. Then I hope that I will meet you there, and thank you very much for being here. It's been a pleasure to chat with you there, and it was a quite dynamic class, and I like it very much, enjoy it very much. I hope to see you on the next live class. Until then, keep pushing your ROS learning.